Mathematics in the modern world is a course where the demonstration of mathematical concepts extends beyond the numbers and letters that we tackle in calculus. For one, we've learned about mathematics as a language where logic and reasoning are given focus. These are integral aspects to the functional human being. Functional in relation to the world, that is, their interaction with the rest of society and other elements of life that they live. Well, I wouldn't say I'm fully functioning well in this world because I indeed struggle with social cues as I was not able to experience a lot of what life had to offer as a child, and what I just mentioned could actually be an application of that lesson wherein propositions are involved. However, I'd say it's quite a bit of a subjective truth since it's based on my perspective, based on how I evaluate information and experiences, as taught in philosophy back in senior high. So for this discussion, I say let's try to be a bit more practical such that we deal with objective truths. For that, let's try to tackle technical concepts, as I think I am a bit more familiar with such concepts than subjective perspectives, wherein there's numerous schools of thought in place. At least with established technical concepts, we could mess around with different parameters and find out the outcome. So, let me share some information about how logic and reasoning can be applied in real life based on hands on experiences. For one, let's talk about programming. The use of propositions is very evident here. Well, I guess not everything here would be propositions, since we've previously defined propositions to be declarative statements, as some sentences may be more appropriately categorized as imperative. And you may ask why? Because it's essentially a command, even though it may not look like one. You'll understand what I mean with an example, so here is one. Okay, let me run this program and show you a brief demonstration. So it's telling me to guess the word it has in mind. I'm thinking maybe if the word it's thinking of is crush? Oh, unfortunately. So I got it wrong. And it's telling me that the correct word is actually live. Okay. So now let's talk about how it works. Like, how is this program working anyway? So the syntax you see in this program basically works as a recognizable command or an instruction that programmers would call to execute a certain function. For example, import random. Here, the first line means that we, as a programmer, if we add the signal word import as a line in our program, then we are telling the computer to import the random library for us. That process typically happens in the background and we don't really see it in our IDE. But see that? We are actually applying logic at this point already. And at this level, propositions are already involved. Now, let me explain the rest of the code where you'd see how conditional, otherwise more familiarly written as if-then statements, can actually be applied so that we could create a program that performs the functionality we want. So, in here we will be showing like how you could customize it so that it suits the functionality that you want. Since these ones are kind of predefined, right? These are ones that are already recognized by the language as a like when it's communicating with the computer. Okay, so here this third line, user underscore input is equal to input guess the word I have in mind. So this line basically allows us to ask for a user input by placing the prompt guess the word I'm thinking of. Whatever the user inputs is then treated as a string and assigned to the variable called user input, as indicated by the equal sign. Now, on our next line, we have word underscore pool is equal to an array of strings, believe, laugh, love, like, live, you, crush. So here we are actually defining our array. I made the variable name into word pool and listed the words that the program would choose words from. So that's actually the purpose of this, since we want the program to select a word from the word pool, just like how it works in those test test types, right? So this word pool is a variable with a type array. So now what's cool about arrays is that if we want to access a specific word or a specific element of the array, we can do that by defining the position or the index of the word on that array. In my case, I wanted the program to be the one doing that for me, to be the one that selects the specific position for me. So on this line, on our sixth line, this is actually a random integer generator. It actually just basically tells us that choose a random integer from 0 to 6. Since it is actually very responsive according to how much we adjust to this array, because it simply counts the length of the array and then just subtracts it by 1. Right now, the program is trying to find an integer from the range 0 to 6. And then it will assign that number to R. Now, here's our conditional statement, starting on our 8th line. If the user input matches the string, as indicated in the position R, then the program will print a text that says that the word the user entered is right. Else just means that the user input and the specific word and the specific index of array does not match. In other words, if the previous condition is false, then proceed with the operation indicated below. So this is actually the operation that it will execute if this is false. Okay, so if the 8th line, if this line is false, then it will be moving to this line and then executing this. Okay, so another application of this lesson, specifically logical connectives, and yes, that includes the truth table, can be found on spreadsheet softwares that utilize functions to automate tasks. So usually this involves data. Now, to automate tasks in the right manner, you would want to make sure that your nested functions are correctly written. So let me show you a spreadsheet that shows my requirements checklist and flowchart. So here on column I actually have a tracker that checks whether I have passed a specific subject as determined by the long equation here. So it takes into account each subject, right? Because each row has a specific subject. So if I did pass a prerequisite, it would output true. Now with conditional formatting, I made it more accommodating for me as the user, as now there is a visual indicator. So actually, if it's true, it would be color green. So one may think it's not that useful, right? But well, sometimes I actually do think that's the case because I initially made this spreadsheet out of boredom and have it updated whenever I am procrastinating. However, it serves as my personal tracker to know whether I am allowed to take a specific course whenever the My LaSalle portal is down. So in a way, it's actually really useful. Actually, bear with me. Let me just explain a bit more before we move on to the next topic. So, to ensure that it will be able to account for various situations, allowing semi-automation of data, several logical connectives have been incorporated into the function. So actually, you would see here if and if, not, if error, among many others. So, well, I don't actually have a proper gauge if this is the most optimized way I could have written the function, but so far, it has worked well for me, and for that, I left it as is. And here's the full equation, if you may. Actually have also uploaded this template, a template of this file, on the De La Salle University templates, so found in Google Sheets. Moving on, I'm the type to go about my life without following a specific guide because I thought that by doing so, I'm leading myself to the path to happiness. By that I mean that by not setting very specific expectations for myself, I will not have to deal with the emotional consequences. But here in this course, we learn of concepts that involve intricate planning, rather strategic planning, whereby choices are made by following a certain algorithm. In real life, the payoffs or any related numerical value of such a matter, which are used in these strategies, are not often known, as life is not an ideal system where factors may be completely controlled and the possibility of outcomes may be perfectly calculated. Moreover, who is to put a number on something when there are different perspectives on different matters, right? For example, the prisoner's problem. Yeah. Well, let's say you arrive with the option that shows the least amount of jail time for both correspondents. However, the corrective facility is actually the only place that provides you with your necessities, and you may eventually consider jail to be a decent place to stay in. I'm not insinuating or implying that this thinking or this mindset is right. I'm simply saying that this kind of perspective where less is more is possible. Thus, these solutions may not be exactly a perfect solution that truly benefits us, but we can try anyway, right? In this exhaustive life, I believe that we can try if we think that it will benefit us in some way. Maybe we could integrate mathematics and finances into mathematics and decision sciences, since the world we live in involves money in almost everything, right? Sounds a bit pessimistic in it, right? But it's real, come on. And let's not ignore that. Anyway, we can use these strategies we learned in managing our money, especially when we want to find the appropriate method to grow our money in the way that we want it to. I believe this is especially useful for personal projects, which will be most likely funded with our own pockets, right? Let's say if I want to get started with my life vacation, that is charity work that provides primarily food and accommodation to community members, then I would have to get funds from somewhere. If indeed I am still in the early stages of such work, but I want a physical location that they could go to, then I'd say I should look for the maximum strategy. So recall, a maximum strategy minimizes the maximum possible loss. So in the future, I would probably be earning my own money, right? And I would want to find a strategy that like minimizes the loss that I could get, because we don't want our money to keep draining, right? Well, from not making better decisions, better informed decisions. Like, come on. I believe that this is really important if you want to save up enough money to be able to afford and provide daily necessities to hundreds of people. Now, what about mathematics for efficiency? We could conveniently use the assignment problem so that we would be able to find an optimal allocation of resources, one of which is time. Okay. I'll be a bit more specific. As a manufacturing engineering student, we actually get to operate on multiple machines. However, some machines are more efficient than others with respect to the time it takes to complete the same work. Now, using that logic, we could assign the simplest model to the 3D printing machine that takes a bit more time than others if you are aiming to have all outputs completed around the same time. Well, that's a base case scenario, I guess, but models tend to get quite integrated with varying parts, especially when we are designing actual functional products and not just the ones you would use for display or the ones you would see for display. If we do not mind quote unquote wasting money on resources, we could use the CNC machine instead. So, CNC involves subtractive manufacturing. Thus, unlike 3D printing, which is additive manufacturing, we could end up with a lot of waste. CNC machines do take quite some time to set up though, but it is more practical to use if we are trying to mass produce a particular product. But let's see how these machines will be improved in later advancements in technology. So, actually, it was only in this course wherein I was able to learn about different algorithms to reach a decision It was confusing but definitely interesting because I didn't know you could use tables for that. Well, I actually thought that maybe I could create a program that will help me reach a specific decision, even though, if I'm being utterly honest, it's not my cup of tea, as I would like to follow my heart due to my faith and God's will. So, what about mathematics and nature and the arts? There's so many useful structures that we could try to learn and replicate from nature in order to bring a more reinforced structural base. Okay, since I haven't had much experience with the creation of hardware, I'd like for us to compare the fractal design found in the branching of trees as with nested functions in a program. I guess it's kind of like iteration, but I'm not that familiar with that. Okay, let's talk about the structure. So you see, you'd have a function, and inside it are a bunch of functions, which you could customize and call as long as you structured it in a proper manner. Your program can have a lot of these functions, especially if you want to make an interactive environment. So that was actually the first thing I thought of when we were shown a video that talked about how the branching in trees are also considered as fractals. So I'm thinking of it as like an algorithm where there is a main structure and a substructure which you could repeat several times. And it works. It works because you understood how the priority of functions. Overall, I'd say I enjoyed doing the truth table the most, just because it was easy, as I'm someone who's fond of maximizing technology in terms of what Google's spreadsheet and different programming languages have to offer. However, the most interesting thing was probably encryption and decryption. As someone who doesn't quite have a private life, I don't actually have a clue on when I would use it, but learning about how certain algorithms work, felt like I was in some spy movie that I would have loved as a kid. Needless to say, I do want to learn more about it, since the discussion for that was, I'd say, quite rushed. So it was difficult to understand the concept right on the dot. Now, if I were to summarize my experience in mathematics in the modern world in three words, I'd say that it's complex, it's fun, and exciting. And that's it for my presentation. This has been Abasolo, and thank you for listening.